Hello, welcome again to Friends in Tech Automation. We provide practical trainings on PLC, SCADA, and IoT. Now, in this video, this is part 2 of subroutines. So we explain what's a subroutine, and we say that subroutine is just a section of a PLC program that is reusable. So it is used to eliminate repetitive tasks. So a subroutine is just a piece of program that performs a specific task. Now, we say that in TIA Portal, you can develop subroutines using function, that is just FC block, but you can also use function block, FB. So I tried to explain the difference between function and function block in TIA Portal. We say that with function block, you have a data block called instance data block. But with function, you don't have instance data block. So function is just a calculator. For example, a calculator, you just perform arithmetic operation, but it doesn't store that answer. But with function block, it remembers the state, the previous state, okay? It will remember the previous answer. That is what is function block. So in this video, we want to program a subroutine. We want to develop a subroutine using function block. Now, if you come to TIA Portal here, this is what we did. And we developed a function called analog scaling. You can see it is FC1. Hope this is very clear. Let me try to use zoom here. So you see this here. If you come to program blocks, we have main, we have FC1, which is analog scaling. If you double click on this, you're just opening analog scaling block itself, which is this here. So after developing this analog scaling block, you have to invoke it, or you have to call it in your main program. So if I open main program here, you see we have called. So calling analog scaling function or a subroutine, we have called it in network number 4. All right. So we are saying that instead of using FC1, you can also use FB, function block. So just double click on add new block here. So I want you to select function block. So you can see description here. Function blocks are code blocks that store their values permanently in instance data blocks so that they remain there after the block has been executed. Simple. Now let's give an example. You are in a power plant. Let's say thermal power plant. And with thermal power plants, you need what is called cooling towers. So these cooling towers are just fans run by motors. So many of them. So you want to develop a program to run, let's say, 5 motors or 5 fans. So instead of developing 5 latching circuits or latching diagrams for each motor, the only thing you need to do here is develop one. Then call it 5 times. If you have 5 fans. If you have 20, call it 20 times. That is what is called a subroutine. So subroutine is used to implement repetitive tasks. So let's call this block 1 motor control. Let's call it motor control. Motor control. Then okay, so you have to select the language that you want to use here. So let's just go with ladder. If you don't want to work with ladder, you can select FBD, you can select STL, or you can select graph. So we just go with ladder, then okay. That's it. So give it a moment. So we have FB1. I'll just go offline here. So you see I have FB1. This FB1, this is function block. So the moment you create FB1, the moment you create an FB1 here, this here, it will come with instance block, instance data block. It will come with instance data block. So if you expand block interface here, you can create those placeholders. So the simple thing we want to do here is run a motor. How do you run a motor? It's simple. You need start, you need stop, and you need an output here. So for you to start a motor, you need an input. So the input here will be start button. So this is where you will connect your start button. All right. So this is where you'll connect your start button. Remember, start button is just Boolean. Other than start button, you also need stop button. You also need stop button or stop push button. That's it. At the output, you only need motor. So you need to create a placeholder for motor. That's it. So let's say this is normally open. So this here will be normally open. This can be normally closed for stop, but you have to be careful here with what hardware you are using. So you need to add a latch here, then just complete this. That's it. So this here will be stop button, and we are using this placeholder here. So this is temporary variable. Then we have start. That's it. Then this is motor. That's it. Then since we need latching, you have to reference motor here. That's it. So you have that here, and you can save this project. Save your project. Then, so after creating this here, you need to call this subroutine to your main program, OB1. If you fail to call it, it won't run. It won't work in simple terms. So go to main OB1. Then this network number 5, let's say calling motor control subroutine or function. Okay, subroutine or function. So again, we say that we have two ways of calling a subroutine to your main program. The first, just select this empty box, place it here, then double click on those question marks, then type motor control, the name of your subroutine, this here. That's it. But then you have to create a data block. The moment you call or you invoke FB1, you have to give it an instance. So this instance, let's call it motor control 1, because you can have several motors. You can have motor 1, motor 2, motor 3, motor 4, motor 5. So let's call it motor 1 dB. So motor dB1, okay? Motor dB1. That's it. Then just click OK. So this is motor dB1. So we have just created this, and the moment you call it motor dB1, so you can see here we have an instance dB. Motor dB1. I'll just remove this guy here. And we are not interested with you here. So we have motor dB1 here. If you double click on this here, motor dB1, this is what you'll get in motor dB1. So go back to your main program here. So you have to give this start stop motor. So I don't know if I have an input called start, maybe. So I start button 1, then stop button 1. Perfect. Then we can have motor 1. That's it. So you see this here, this is to run your first motor. This is to run your first motor. But we are saying that the reason for using subroutines is try to implement repetitive tasks. So instead of developing 10 latching networks for 10 motors, I just have one here, this here. But I can call it multiple times in the main program. So this is for motor 1. Let's say motor 1. This is for motor 1. Let's say that you want to call for motor 2. So you can call it here in network number 6, motor 2. Motor 2, all right? Motor 2. Then another way of calling your subroutine, just drag the name of your subroutine here, function, drag it to network number 6 and place it here. That's it. And this DB here, let's call it motor DB2. Motor DB2. That's it. Motor DB2. So here I will create start button. Start button 2. Start button 2. And I'll define it as a global input, okay? I'll define it as a global input. That's it. Then here I have to define stop button. Stop button 2. That's it. So I define this again as global input. It's just an input to the PLC. Global input, that's it. Then this will be motor 2. So we call this motor 2. And we define it as global output. All right. Global output. That's it. So what happens if you try to simulate this here? So I stop my CPU. Then I will download the program. Select consistent download. If you fail to select consistent download, what will happen is that you'll not be able to monitor your input and output. Perfect. Good. Then you can monitor input output. Take it to run mode. That's it. So here I'll just change state of this, for example, motor 1, motor 2. So I can click on start button. So let me just remove this here and add another input variable. So I have start button 1, which is I 0.0. So if I click I 0.0, I expect motor 1 to run. So motor 1 is true. So motor 1 is running. So motor 1 is true. Sorry. And motor 2 is false. Motor 2 is false. Motor 2 is false. So if I want motor 2 to run, this is what I will do. If I want motor 2 to run, I'll select I 0.7, this here. Nope. And now motor 2 is running. So motor 2 is running, and motor 1 is running as well. So motor 1 is true, motor 2 is true. And I can stop this here. I just remove this. So if I engage I 1.0, this is 1.0. Sorry, let me just change this here. So 1.0 is this here. Oh, it stops the motor. If you release, it starts the motor. So I mean, that's how you can use subroutines. You know, you can ask yourself this question: why am I using FC and FB? There's something you should, and I want you to try this yourself. This here, I want you to implement motor control. All right, I want you to implement motor control subroutine using function FC. And I want you to call it 2 times or 3 times. Let's say you have 3 motors. So I want you to call it 3 times, but instead of using FB1, kindly use FC1, and you will see the difference. And that's the time you realize that, hey, I can't use FC here. So FC is only used if you don't want to store the output, or if you don't want to remember what was the output. Okay, that's the only time you need to use FC. So these are some cases where you'll apply FC and where you'll apply FB. For example, if you just want to do analog scaling of inputs, use FC. If you want to do mathematical calculations, for example, we want to do speed calculation of a motor. So we want to know this motor is running at this RPM. So if you want to do speed calculations using an encoder, so you do use FC function. Okay, use function block. If you want to perform interlocks logics, you want to do mode selection logic, auto manual, use FC. But what about FB? So for motor control like this one here, use FB. For pump control, use FB. For valve control, use FB. And for alarm latching also, use FB. This is a very vital topic. Why? Because subroutines supports what is called modular programming. It's very important. Instead of developing your entire program in main OB1, you can break your program into modules. So subroutine supports modular programming. So thank you for watching this video. Give it a like and subscribe to our channel. Also share our content.